What's up guys, and welcome to the second part of this tutorial on mechanical energy and conservation of mechanical energy. So if you missed the first video, we went over some definitions and did two examples as well as this proof here. But yeah, you should go watch that, and in this video we're going to go through another two examples, okay, because the best way to see if you understand this is to go through examples. Okay, so example 3. So basically we have a cart first at position 1 and then traveling to position 2. Position 2 is elevated above position 1 at 0.5 meters. Okay, V2 is also 5 meters, and we also know that the mass of the cart is 5 kilograms. So basically it says calculate V1. Okay, and how are we going to do that? We are going to use the conservation of mechanical energy. So the mechanical energy at 1 must be equal to our mechanical energy at position 2. So mechanical energy is made up of potential energy at 1 plus the kinetic energy at 1 is equal to the potential energy at 2 plus the kinetic energy at point 2. But we're also picking our datum here. So at position 1, our height is 0, so EP is equal to 0. So what we're left with is a half m V1 squared is equal to mgh2 plus a half mv2 squared. Okay, these masses all cancel, so we're left with a half v1 squared is equal to g, which is 9,8, times our height at 2, which is 0.5 meters, okay, plus a half times the v2, which is 5 squared. Okay, then we can plug that into our calculator and we get that, okay, v1 squared comes out as 34,8. So if we square root both sides, we can calculate v1. v1 is equal to 5, let's say 9 meters per second. Okay, and we want the velocity, so we know it needs a direction, so it is right. Okay, then the next part of the question basically says that we introduce some kind of friction at the top of the slope. Okay, so we have force friction, which is equal to 10 newtons. Okay, and we're told to draw the free body diagram at position 2. Okay, so we have our 5 kilogram point mass right there, and we know we're going to have mg acting downwards, and we know we're going to have the normal force acting upwards, and we're going to have this force friction acting to the left. Okay, next it says calculate the acceleration. Okay, so we're going to use Newton's second law, which says that if sum of the forces, so we're going to take the sum of the forces in the rightwards direction is equal to the mass times the acceleration in the rightwards direction. Okay, so we have a 10 Newton force here, but it's acting to the left, so minus 10 is going to be equal to our mass, which is 5, times our acceleration. So our acceleration is equal to minus 2 meters per second, which we can say is 2 meters per second squared, and that's acting to the left. Okay, and then it says calculate how far, so calculate how far the cart goes before coming to rest. Okay, so how are we going to do this? Okay, so we know we're experiencing a constant acceleration here, so we can use, this is the perfect place to use some UVATs. Okay, our initial velocity is 5 meters per second. Our final velocity is 0, our acceleration is minus 2, our time is an unknown, and our displacement is also an unknown, which we want. So let's see, what equation can we use? We can use the equation v squared is equal to u squared plus 2as. So we're left with 0 squared is equal to 5 squared plus 2 times our acceleration times s. Okay, and if we calculate s, is equal to 6,25 meters. Okay, and that's going to be towards the right. Okay, so not too difficult. It's an interesting question because we use mechanical energy, a little bit of Newton second, and UVAT. Okay. So the next question, what we have is we have a skier or someone going down a sledge on a slope of some sort. They have a velocity at the top of 4 meters per second. Their mass is 50 kilograms, and the slope has a distance of 75 meters. And has an angle of 10 degrees. Okay, and we want to calculate VB. Okay, so I'm sure you guys guessed it already. We're going to use the conservation of mechanical energy. So the mechanical energy at the top must be equal to our mechanical energy at the bottom. So we have mg. Okay, so let's say EP at the top plus EK at the top is equal to EP at the bottom plus EK at the bottom. Again, we're going to pick our datum at the bottom. Okay, so then our EP at the bottom is equal to 0. So then what we're left with is mgh at the top plus a half mv squared at the top is equal to a half mv squared at the bottom. Okay, these masses are going to cancel. So what we're left with is 9,8 times our height at the top. Okay, so what is the height? Okay, is it the 75 meters? No, okay, right? Our height is this height right here, h. Okay, and if we look at this, what we actually have is this height right here. We have 10, we have 75, and we have a right angled triangle, right? So we can say h is actually equal to 75 sine 10. So 75 sine 10 plus a half times our velocity at the top, which is 4 squared, is equal to a half times the velocity at the bottom squared. So we can say that the velocity at the bottom squared is going to be 9.8 times 75 times sine 10. We can show you in degrees, plus a half times 4 squared and multiply everything by 2 is equal to 271,26. And if we square root both sides, we get that the velocity at the bottom is equal to 16,47 meters per second. Okay, and let's say we just want the magnitude. So that's our final answer. Okay, cool stuff, guys. So we've gone through a number of examples. They're all pretty much the same thing. There's nothing too difficult with this section in particular. So in the next video, we're going to move on from this, and we're going to go into momentum and elastic and inelastic collisions. So yeah, get ready for that. I hope you guys found this video useful, and thanks for watching.